Okay, the story I'm about to tell you doesn't quite add up. Can you figure out why? Hi, I'm Archie McLaughlin, this is The History Show, and when it comes to the infamous tale of Archimedes running naked through the streets shouting Eureka, historians, scientists, and YouTube hosts all have some big questions, such as, did it happen at all? And if it didn't, does that really matter? Welcome to The History Show. Now, the place a lot of us probably heard about Archimedes wasn't actually in history class, but in science. Well, unless you were obsessed with the owl in the Sword in the Stone movie, which in my opinion is a deeply underrated Disney classic. Very similar to Cars 2 in that way. However, the Archimedes I'm talking about was not some crotchety cartoon owl, but an ancient Greek mathematician and inventor from 3rd century BCE. Now, this was still a few centuries or so after other famous Greek thinkers like Pythagoras, Socrates, Plato, and Aristotle, but still before the Roman Empire, we're all thinking about multiple times a day, officially started. Some people call this the golden age of Greek mathematics, and real fundamental work was being done in arithmetic and geometry by guys like our boy Archimedes, with a lot of key implications for things like levers and buoyancy, and finding the volume of irregular shapes. It's a beautiful day in Syracuse, the bustling Greek city-state on the island of Sicily. I'm just going to assume it was beautiful because they're in the Mediterranean. When is it not beautiful there? But King Hiram, the king of Syracuse, has just commissioned a gold crown from a local goldsmith and supplied him with the exact amount of gold the goldsmith should need to make the crown. But lo, there is trickery afoot, or at least suspected trickery. After receiving the brand new super spiffy solid gold crown, there's a tongue twister, whispers get back to King Hiram that the goldsmith might have cheated him out of some of the gold, and the crown on his head might not be solid gold after all, and there could be, get this, silver mixed in with it. But luckily King Hiram knows a pretty talented STEM guy who might be able to help him out. Bring me Archimedes! This is what I imagine the king sounded like. I think it's pretty accurate. Archimedes, only you can tell me if the would-be deceiver has attempted to turn silver into gold. By this point, like, the king is gesturing menacingly at the goldsmith who's like standing in the corner, kind of cowering. Go and do not return without the golden truth. And then Archimedes like walks away. At least that's what I'm thinking of. Anyway, Archimedes is now faced with a tricky problem. How is he supposed to tell if all that glitters isn't really gold? He starts by thinking about all the ways gold is different from silver. One is color, but that doesn't really help here. But he also knows that gold and silver have different densities, which in simple words is how heavy something is for its size. Gold is more dense than silver, so even if you have two chunks that have the same weight or mass, the silver thing is going to be bigger and take up more space. It's going to have a bigger volume, and in math terms, we can describe this relationship as density equals mass divided by volume. And Archimedes already knows the mass of the crown. Scales were a thing back then. Plus, it's the same mass as the gold King Hiram handed over. The goldsmith wasn't that much of a nitwit. So if the crown had the same mass as the original gold and the same volume, Archimedes and the king could be sure it had the same density too and was 100% certified gold. But if its volume was larger than a hunk of gold of the same mass, it meant it was less dense, and it would be clear that somebody had been tampering with it. But there's also still a bit of a problem. When's the last time you tried to measure the volume of a crown? See, crowns, especially spectacular gold ones specifically commissioned by finicky kings, are irregularly shaped. Like, it's not a cube where we could just multiply the width, the height, and the depth and then find the volume. It's not even a sphere, which is a little trickier because we have to bring pi into things, but we could still measure the radius of it and bam, 4/3 pi r cubed, easy peasy. Actually, Archimedes is the one we give credit to for that observation. And he couldn't very well cut up the king's new crown into regularly sized pieces just for the sake of accessible geometry. And for a while, this stumps Archimedes. And like so many of us, when the going gets tough, Archimedes takes a bath. That's where Archimedes makes a key observation. When he steps into the bath, the water level rises. Now, I'm no fantastic scientist, but something's going on here. Well, here's the real insight. Say you know exactly how much water is in the bath before you step in. Then say you can measure exactly how much the water level rose after you stepped in. Subtract the new water level from the old water level, And you have a measurement of how much space your body added to the bath, your volume. And if he can use water to measure the volume of his very irregularly shaped body, that means he can use it to measure the volume of the crown too. And all they have to do is dunk it in some water and then measure that water level difference. Eureka! Crown volume! And so, thrilled by his own insight, Archimedes leaps from the bath, no clothes in sight, and streaks through the streets of Syracuse. Seems like a tad bit of an overreaction, but to each their own. Once they actually measured the crown's volume, it turns out the rumors were worth listening to. The crown took up more volume and therefore was less dense than pure gold and more dense than pure silver, meaning the goldsmith had in fact removed some of the original gold and replaced it with an equal weight of silver. Or that's the story anyway. But here's where things don't quite add up, where the golden patina starts to wear a bit thin, if you know what I mean. First off, even though the most common version of the story definitely involves Archimedes, a bath, and a crown, I struggled with exactly how to share it with you all because there are so many freaking little small tweaks depending on who's telling it. Like sometimes the crown is drawn like a crown worn by European monarchs. You know what I'm talking about? Maybe it's a diadem? I don't know. Just to say, it was very hard to Google. But other versions describe the crown as a wreath of gold leaves. Very similar to this, which probably makes more sense. This is the ancient Greek world after all, and this is much more their fashion vibe. I think I look good in this. And the crown was maybe not for the king himself, but for the head of a god or goddess statue in an important religious temple. That means it was a holy object that Archimedes couldn't damage to try and figure out if the king had been swindled. I low-key want to keep this on for the rest of the video, but I won't. Should I? No. Other versions debate what exactly got submerged in water after Archimedes' moment of inspiration. Sometimes he's sticking the crown itself in water and measuring how much water is displaced somehow, like in the version that I shared. Sometimes he's sticking lumps of gold and silver in there. Sometimes he's putting a lump of gold of the same weight in the bowl, filling the bowl up with water, then removing the gold, then sticking the crown in to see if it fills back up to the brim or overflows. Essentially what I'm getting at is it varies, and all these discrepancies make the story a little sus. And there's debate about my personal favorite moment too, when Archimedes went streaking down the streets of Syracuse. It's included in a lot of versions, but according to the encyclopedia website Britannica, which I consider to be a step up from Wikipedia in many ways, that's a bit of an embellishment. Now, you might be asking, well, why don't we just go back to the source? And that brings us to our second issue. As far as we can tell from records that survived, Archimedes himself never wrote about this event, which isn't inherently a problem, but neither did anyone else who was actually there. Unless there's a writing of his that didn't survive, the earliest account we have comes from a Roman architect, engineer, and writer named Vitruvius. This was in 1st century BCE, around 200 years after the whole situation was supposed to have happened. Even if it did happen, and there was gold and a crown and a bath, that's a long time for the exact details to survive before being documented. Think of the game Telephone, for example, where you have to relay the message down the line, but it's 20 people and everyone has to wait 10 years to repeat what they thought they heard. And third, the science isn't quite sciencing. In theory, the whole displaced water thing works, but in reality, there end up being a lot more variables that might have gotten in Archimedes' way if this was truly the method he used. And if this was the method he used, it's physically very hard to do this experiment. The crown still had to look like solid gold. So there couldn't have been that much silver. And in that case, even if it was 30% silver, the measurements become really small. We're talking fractions of millimeters here. And that could easily be attributed to something like air bubbles on the crown or some property of water surface tension. Which, by the way, what's even happening here? Water surface tension. Somebody get Hank on this. Now, I won't get into all the math here because this is the history show, not the math show, though I'm sure that would be a gold medal success. If you do want precise figures, check out the link in the description for a whole NYU site on Archimedes, or virtual book as he calls it, put together by Dr. Chris Rories, an emeritus professor at Drexel University, who's considered to be one of the world's leading experts on Archimedes. But rest assured, when it comes to submerging some crowns in some bathwater, it would be basically impossible to tell the difference with the naked eye. Others, including my boy Galileo, point out another issue, namely that the common story with the crown and the bath doesn't actually use principles Archimedes wrote about or is remembered for. When we think of Archimedes, we're often thinking about the law of buoyancy, which we call Archimedes' principle. Basically, that an object submerged in water is pushed up by a force equal to the amount of water that it displaces. It's how boats work. And even though it does have to do with shoving something underwater to see what happens, the law of buoyancy has to do with, well, buoyancy, and not finding the volume of an irregular solid. He's also remembered as being really into levers. You know, like long beams that can help you lift really heavy stuff that you wouldn't be able to otherwise by reducing the force required according to its distance to the fulcrum or hinge point. Again, I didn't notice any levers in the bathtub story. So what really happened? Here's what Dr. Rorris, the Archimedes expert, and Galileo think is plausible. Since Archimedes did a lot of work in the laws of buoyancy and the law of the lever, they figure Archimedes' real Eureka moment probably uses those ideas. So what if instead of trying to measure tiny amounts of water, we dangle the crown from one end of the scale, which uses levers, and put a hunk of gold on the other end equal to its weight, and then dunk that into water? Well, in practice, the law of buoyancy means that something small and dense sinks more than something big and less dense, even if they have the same weight. Eureka! That means if the whole shebang with the crown, the gold, and the scale were dunked into water, if the crown was a mix of silver and gold rather than just pure gold, it would be less dense than the hunk on the other end of the scale, and therefore displace more water. That means there's more water pushing up on the crown, making it float more than the pure gold, registering a difference on the scale. And if we were to make some realistic assumptions, the difference could be somewhere around 13 grams. Both Galileo and Dr. Rorris like this version because it also makes better use of the technology available at the time. They say that a scale that would have been able to measure this difference would have been widely available. And this version doesn't mess with all the surface tension issues and such, because everything just stays underwater. You're not like dunking anything in and out. But there's one last plot twist to explore, and it really calls into question pretty much everything I thought I knew about Archimedes and this story. Are you ready? What if the crown we've spent so much time discussing maybe wasn't even a crown at all? It all comes down to a question of translation. In Latin, a crown is a corona, which again, I don't speak Latin, but my high school Spanish is coming in really handy here. But in ancient Greek, corone is a keel, like the keel of a massive ship. So what if a bit of mistranslation happens somewhere down the line? That's certainly the opinion of classic scholar Armand Diangor, who spent his career researching, writing, and learning about ancient Greek language and culture. The massive ship in question was the Syracusia, which could have been the largest ship to sail in all of antiquity. And the version of the story does have a lot of the same characters. Here's how this story goes. It's still a beautiful day in Syracuse, of course, but this time King Hieron wants to build a ship 50 times bigger than any standard warship. So he calls for Archimedes to oversee the project. Archimedes, project manage my giant ship build. Now, one of the key challenges here does have to do with buoyancy, which makes this version seem plausible. The Syracusia was supposed to be a big-ass ship with more luxury accoutrements than even the Titanic, making it a spectacular floating palace. Like, one account says that the top deck of the ship was supposed to be supported by giant statues of Atlas holding the world on his back, rather than just plain beams. I don't know how that would work, but it sounds super sick. But unlike the Titanic, sinking was not going to be an option for this ship's maiden voyage. Sinking is not an option! I think my King Hieron voice is coming along. So Archimedes had to figure out how to design the ship so that even fully decked out, it would still float. He figured that as long as the keel was shaped to displace more water than however much the ship weighed, it would float. Eureka! Again! Thanks, laws of buoyancy! So could crown have gotten confused with keel somewhere down the line? Maybe. I mean, remember, Vitruvius didn't write his story until 200 years after Archimedes' Eureka moment, whatever it was. One thing we do know is that the Syracusia existed, but it only sailed once, probably because it was too expensive and big for almost any port. Which is hilarious that they built something so sick they couldn't even use it. So was it a crown or was it a ship? Is there any way to really know what prompted the Eureka? And really, do we even care? And yes, of course, in general, we do care. We'll get into massive issues if we just start declaring things to be true without considering all of the evidence. Like if we'd left it at the sun and all the planets revolve around the Earth, we'd maybe never have smartphones. I'm serious, and maybe we'd have to go back to hanging out with our friends in real life. No, I'm kidding, that would be weird. And not asking questions is just not in our human nature. We're curious people. We like figuring stuff out. We want to read and reread and retranslate and see if there's some idea we missed that might unlock a new invention or a new explanation for why we are the way we are and how we got here. But even though here at the History Show, we're obviously concerned with the facts of, well, history, for this particular historical episode, maybe we don't care. That sounds provocative, but here's why. I watched and read a ton of retellings of the Archimedes story, and the comments on all of them were filled with folks saying versions of, wow, now I finally understand buoyancy or density or the Archimedes principle. History, or even just storytelling in general, do something that pure science equations can't. Maybe this story has lasted for over 2,000 years because science needs history and storytelling and imagination to make things understandable and memorable, and to make people care. So whether you think it was a crown or a wreath or a ship that sent Archimedes shouting Eureka streaking through the streets, we might never know what really went down. But you know what I do know now? The law of buoyancy. And today, like Archimedes finding the silver mixed with the gold, we're tasked with figuring out how much myth is mixed with our facts. Thank you to everybody who helped make this episode. If you have any other buried historical stories you want us to dig up, let us know in the comments. If you see stories below that you like, you can upvote them and we'll add them to our ever-growing list of topics. Also, if you want to see what we're up to, you can join the Complexly newsletter by visiting complexly.com. I'm Arjun McLaughlin, and I will see you in the next episode.